7.3 is on one sample proportion test. We're going to be able to test hypotheses about a population proportion. So let's look at the overview sheet. We are now working with proportions, which are qualitative. We're on the right-hand side, so we're going to be using number 7 on the calculator sheet. Here are our criteria that we need to look for. In this section, we will look at hypothesis tests for the population proportion P. This is where you might be curious if the proportion of students who smoke at your school is lower than the proportion in your area, or you could question if the proportion of accidents caused by teenage drivers who do not have a driver's education class is more than the national proportion. Here's the steps for a hypothesis for one population proportion. You're going to state the random variable. So that's now P, and then P hat, and then P will be the proportion of all objects. We're going to identify N and X, so the number of successes out of the total, and then state and check assumptions, random. There are only 2 categories for each object. So driver's education versus no driver's education. C, check the sampling distribution. P hat is normally approximately normal. Check those 2. State the null alternative and the alpha. Use number 7. And then this is all the same like we've seen before. Recall P hat is equal to X over N, so number of successes over your sample size. A concern was raised in Australia that the percentage of deaths of Aboriginal prisoners was higher than the percent of deaths of non-Aboriginal prisoners, which is 0.27%. A sample of 6 years of data was collected, and it was found that out of the 14,495 Aboriginal prisoners, 51 died. Does the data provide enough evidence to show that the proportion of deaths of Aboriginal prisoners is more than 0.27%? Use alpha equaling 0.05. Okay, let's first start with our random variables. So P hat is 14,495. Aboriginal prisoners who die. And then P is the population parameter for proportion. And this is the proportion of all Aboriginal prisoners who die. Okay, assumptions. The first one was random. We're going to assume that. Two outcomes. They either die or don't. C. N times P has to be greater than or equal to 10. So your N 14,000, the proportion is 0.27, so 14,495. Now you have to divide that by 100, the 0.27%. So you have 0.0027. When you multiply those, you get 39. That is greater than or equal to 10. And then you do N times 1 minus P, which is going to equal 14,446. That's definitely greater than or equal to 10. And we're going to assume the population is greater than or equal to 20. So as a side note, your P hat is X over N. X is going to be how many out of the sample died? 51. And N is the sample size. 3, the null and alternative. P is our parameter, equaling. Okay, it's usually in the question. Does the data provide enough evidence to show that the proportion of deaths is more than 0.27%? So greater than. And our alpha was 0.05. Use number 7 on the calculator sheet. So that says go to Data tab and fill in anything that's in black here. So X, how many died? 51. The total was 14,495. P sub 0 is 0.0027. We're looking greater than. Confidence level is 100 minus alpha as a percent, so 100 minus 5. So P hat, if you did a 51,000 divided by the 14,495, you'd get this. We're looking for the test statistic, so 1.899 and then 0.0288 for the p-value. And Z is this test statistic, 1.899. So we're comparing the P to alpha. It is less than, so we reject the null. So our conclusion is at the 5% level, that's our alpha. If our alpha is 1, it'd be 1% level. Level of significance. There is enough evidence to show that the proportion of all Aboriginal prisoners who die is more than 0.27%. Remember, this last part is from your alternative hypothesis, or HA or H1. Remember, they are the same. Two different ways to write those. All right, let's go on to the next. A researcher who is studying the effects of income levels on breastfeeding of infants hypothesized that countries where income level is lower have a higher rate of infant breastfeeding than higher income countries. It is known that in Germany, considered a high income country by the World Bank, 22% of all babies are breastfed. In Tajikistan, considered a low-income country by the World Bank, researchers found that in a random sample of 500 new mothers, that 125 were breastfeeding their infant. At the 5% level of significance, does this show that more than 22% of all mothers in Tajikistan breastfeed? Okay, so we gotta do the random variable, and then parameter. Okay, so the random variable is p hat, parameter is p. P hat is 500 randomly selected new mothers in Tajikistan who breastfeed. P is the proportion of all new mothers in Tajikistan who breastfeed. Okay. A, random, yes it is. B, either you breastfeed or they breastfeed or not. C, was n times p. Your n is sample of 500. P is 22%. So 500 times 22% is 110. That's greater than or equal to 10. And n times 1 minus p will equal 390. So that's greater than or equal to 10. We're going to assume n is greater than or equal to 20, capital N times 20n. I believe I forgot that up here. 20n. Okay. And our p hat, again, x over n. So 125 are breastfeeding. So 125 over n, which is 500. What's the null and alternative hypothesis? P is our parameter, and we're looking greater than 22 or more than 22%. So greater than 0.22. Alpha was stated to be 0.05 right there. Number 7 on the calculator sheet. X we identified as 125, that was breastfeeding. 500. 125 divided by 500 is p hat is 0.25. And then our parameter for our alternative is 0.22. We're looking for greater than. Our confidence level is still 95. So our test statistic is 1.62 p-value. And we need to change this to greater than, not less than. Is 0.0527. Okay, 0.0527 is greater than our alpha. So we do not reject the null. Do not reject null. Okay, let's state our conclusion. At the 5% level of significance, there is not enough evidence to show that the proportion of new mothers in Tajikistan who breastfeed is more than 22%. Again, this comes from your alternative hypothesis, or HA, depending on what your homework is asking. So this could be HA, one of the two.